In this video, we're going to look at some examples of Lewis structures for ionic compounds. Our first example is calcium bromide. Now, if we look at the neutral calcium atom, calcium is in the second column of the periodic table, so it has 2 valence electrons. So the Lewis structure for a neutral calcium would look like that. A neutral bromine atom, bromine has 7 valence electrons. So we'd have 1, 2, 3, 4, 5, 6, 7. Now, calcium bromide being an ionic compound, I don't want to look at the neutral atoms as I've drawn here, I want to look at the ions. And so calcium typically forms ions with a +2 charge. So if the neutral has 2 valence electrons, then the calcium ion will have, with a +2 charge, will have lost those 2 electrons. And so, in fact, it will have no valence electrons. So the calcium ion is just Ca2+ with no electrons around it. Bromine, being in the second to last column, typically forms -1 charges. So it'll go from 7 valence electrons I have here to 8. So the Lewis structure for the bromine ion, 2, 3, 4, 5, 6, 7, 8. Now when I have ions that have electrons, valence electrons, we like to put those guys in brackets. So my bromine ion would look like that. So I'm almost done now with drawing the Lewis structure for calcium bromide. I have the Lewis structure of the cation, the calcium, and the anion, the bromine. And so all I have to do now is, in my Lewis structure, state how many of each of them I have. And so I have 1 calcium, so I don't need to do anything for it, and I have 2 bromides. So I'll put the 2 there. So that's the Lewis structure for calcium bromide. Let's look at one more example. Okay, in this example, we're not given the formula, we're just told that it's aluminum nitride, or it's the compound formed between aluminum and nitrogen. And so I need to figure out what the formula for this is before I can draw the Lewis structure. So we know that aluminum likes to form +3 ions, and nitrogen likes to form -3 ions. So aluminum nitride will have just 1 of each. So the formula is just AlN. Now this time I'm not going to go through the trouble of drawing the Lewis structures for the neutral atoms. I'm just going to go ahead and draw the ions right off the bat. So aluminum, we know, has 3 valence electrons. Aluminum +3 has no valence electrons. So again, the cation is just the bare ion with no valence electrons. Nitrogen neutral has 5 valence electrons. If it's -3 charge, then it's added 3, so it has 8. And so the nitride ion will get 8 valence electrons. I'll put them in brackets. Say that it's -3. Because in the formula I have just 1 of each. I don't need to put any numbers on here to finish off my Lewis structure. And so this is the final Lewis structure for aluminum nitride. Now if you notice a similarity between the previous Lewis structure and this one, for ionic compounds involving main group elements, which is what we're going to be doing in this class, the cation is very easy. It's always just the bare cation. It's lost all of its valence electrons, and you have to indicate how many there are and what the charge is. The nonmetals always end up with 8 valence electrons, and so they'll all look the same. It's just the atomic symbol. It'll have 8 valence electrons around it, and you indicate the charge, and then you just have to say how many of each of them there are. In this case, there's just 1 and 1, so I don't need to say how many of each ions there are because it's understood to be 1.